welcome to new people, and welcome back to familiar people. So tonight we have a special treat for you. If you've been to a concert, you know, and seen those musicians on stage with the two pianos, that's kind of what's going on here. So Micah Stubbs is presenting tonight, and for those of you that don't follow him on Twitter, I have two things to say. One, follow him on Twitter, because he's a source of some pretty fantastic information, not only from his own visualizations, but he points to interesting things that are going on out there. And in fact, that's how Micah and I met. We met on Twitter, funny enough. And in the last, maybe 8 months, let's say 8 months, 6 to 8 months, Mike has become a really an active member of D3 Bay Area. In fact, the first time we met in person was at my videos. And here's the kind of person Micah is, right? Like, he came in for the first time in the front door, just like everybody else, and then he stayed down there and volunteered to stay down there to let other people in while I came up here, which was just extremely big of him. So Micah's just an incredibly kind, nice, generous, considerate data visualizer. He works at a place called H2O.
That's right.
I'm not sure what they do, but they have AI in their name as well. So it's H2O AI, for those of you who want to look it up. Somebody's at the door. So I'll go get them in a second unless somebody wants to volunteer. Ah, look at that. Thanks, Ian. Micah is going to talk today about some examples. So if you guys have been in the D3 community at all, for any length of time, you've seen blocks.org, right? Everybody familiar with that? Anybody need a refresher course on it? Nobody, good. And then Ian, who very nicely went out to let people in, created something called Block Builder very recently, which actually is kind of an IDE in some ways. It lets you create these visualizations on the web. So using some of that, and like in collaboration with Ian and others, Micah's going to present some pretty cool looking things for us. So without further ado, because I've talked way longer than I intended to, I present to you Micah Stubbs.
Thanks, Imad. Hello, everyone. So I'll shamelessly plug my Twitter handle, Micah Stubbs. I work at this company. We do machine learning and also data visualization for machine learning. So if you're interested in these things, let's talk. We're hiring. So like Simon said, there's this canonical way to share examples in D3. Mike Bostock, who is the person who created this visualization library we have a meetup about, has a page, a website called blocks.org, and you can go on there and post visualizations, post examples. So I'll show one I worked on recently. So it's a matrix of scatter plots. And I want to think about what the right opacity is for the points in the scatter plot. The idea is if you plot multiple points near or on top of each other, how opaque or transparent they are influences how many points you can perceive. And I didn't know the right number. I thought maybe it was different than it was before. And so there's a slider and we can change it. So this is an example of a thing you might want to do. D3 is great because if you have these questions or these impulses, you can go modify the code and it happens. I'm talking about modifying the code because this is a fork. This is a version of one of Kai's blocks. And so this behavior of finding something on the web that you like and changing it and making it yours is actually pretty common in the D3 community. So that's the focus of this talk tonight. So I'm going to follow this link here after Kai's example. And it's a scatter plot matrix, same data. And in the description here, it mentions this other example, scatter plot matrix brushing. So let's follow back there. And so here you have something rather different. The data set is different, and the functionality is different. So this is actually quite cool. So stepping back again, there are the circuits I told you about. Kai's block is notable because it uses this version 4 alpha, this new version of D3 that is being developed. And then mine maybe is interesting because I also use this modern JavaScript, which I think Chrome supports a lot of, like as of recently. So we can get back to the base block. It has a description. The author wrote some text about it, said there was a statistics professor who invented the design, and here's some other tools. It links to what? Another example. So if we follow here, there's a static version of the same chart, the same visualization. So we picked an example, and we can go like 4 hops back. We can see all these other examples that are linked. So I do this because I like to give credit to people when I make an iteration of their work. And I look at this because I'm curious. I see something I like, and I want to find more things, that I also like. So I want to explore this kind of connection. So I should stop and reiterate something Simon said. These blocks you see are just files on a server on the internet. Specifically, they're files on a server that's hosted by GitHub, which is a friendly company that hosts code for free. And inside, you'll see some data, a CSV file, and oh man, we have to scroll forever. There's also an HTML file and an image. Inside this HTML file is some JavaScript and what we could call D3 code. But tonight, the part that is really interesting is this README. So it's a markdown file with some text, and those links, those mentions of other pages. So here's the raw markdown. And forgive the really small text, but you'll see that here is a link out to Blockbuilder or to blocks.org. Blocks.org is this viewer. And Blockbuilder is another viewer for D3 examples that also has an editor, which is really cool. I think Ian's talked about this before. So I'll take a step back. In D3, when I make a single example and it's following this line of work other people have advanced, I like to mention them. So in this talk, when I talk about showing the community structure, showing how people create examples and like the patterns there, I want to cite some earlier work. Some people have explored this and found patterns. So this first tool is called Blocksplorer. It came from a person called Irene Ross, who is super cool. And let's see if I can show you a picture of her face. Pretty prepared, but I'm not that prepared. She is in Boston. There's a company called Oku that they're actively involved in many D3 projects. So there's Irene. She also organizes this conference that I think President Sina will tell us more about in a little bit. So the story goes, and I say the story goes, this is before my time, that she came to an event in the city, talked to a bunch of people and had some ideas, and then on the plane back to Boston, built this tool called Blocksplorer. So Blocksplorer lets you find examples based on functions that they use. So we type in D3, and we can say D3 event, and let's say gm.contour instead. And we see some examples, we see some blocks. So this is a really nice search feature. And it also implies, or has behind it, this interesting data set. All the IDs are the links to the examples and the functions that they use. And so the process of gathering that data set from all these GIFs, which are publicly available sets of files hosted by GitHub, started this community analysis project. So Elijah Meeks gave a talk to this group in 2014 called D3 Introspect, where he showed some graph analysis done on the data set that powers Blocksplorer. So the list of all of the D3 examples and the functions from the library that they use. And so I'll really quickly remind you of this project. So he has this blog post describing it. And he has aspirations to build a whole social network, which might sound crazy, but I also want to do this. He also did some topic modeling or some text visualization, which is quite cool. So this is from a different data set that shows the activity in the D3 community. If I remember right, this is topics that people in the Bay Area D3 meetup mentioned that they're interested in.
Maybe a survey.
And maybe it's survey results like that as well. And so he finds these clusters, people who care about where they're from, what kind of work they do, what kind of causes they are interested in. Yeah, so clusters of words. And the current network visualizations. So at the time, there were perhaps 800 blocks, and there's some instructions. So he has nice controls to change this network, and we can, I think, interact. So these are individual examples. So there is a map of the US that's demonstrating some kind of zooming behavior. It's from Mike Bostock. And there's some properties, some like graph analysis properties that he shows. So he also created a network not where the examples are the nodes, but where the functions themselves are encoded as the nodes or the circles. And so you can see which ones are most central, most commonly used. And so d3.go.path is used by many examples. d3.json, maybe the most widely used. This is how you load data. So it's something that happens all of the time. And I'll share these links. It's really exciting to play with. He included this brush. So this is the number of functions, maybe the number of blocks actually. So if we want like more than 21 and less than or equal to 36, you get this different network structure or a smaller number of links because we've constrained it by this filter. It's a really nice feature. So some earlier work that's been done from a really similar data set to what I'm about to show you. These are Ian's blocks. I have an example from his work next. So more recently, Ian created this block wall, and maybe I can open it and make it larger. And it still works wonderful. So these are all of the blocks, I believe. Are all of them subject to some filtering, perhaps if they have thumbnail images?
It was all of them like 8 months ago or something.
Okay, so in like October, November, last year, these are all the blocks. So you draw a small rectangle or a brick for every example, and when you mouse over, you can see it. You can see the title, the thumbnail if it's there, and if we click, we can travel, we can filter, so there's a smaller number. So this is another view of the activity in aggregate. All the people around the world who are creating D3 examples. What are they creating? What are they interested in? Tell me about the sequence. Is it chronological?
I think so.
Are the old ones at the bottom?
Yeah, I think it was sorted by date.
Yeah, so you have some idea of the, let's see, the patterns. When there is lots of activity or at least lots of blocks with thumbnails, and when there are fewer. So another example of ways people have studied and shown activity in the community. So the data for the visualization I showed before, I think was produced in concert with this project. Blockbuilder has an editor, but it also has this really nice search function. So I visited blockbuilder.org. Oh, full screen. Here we go. Blockbuilder.org/search. And then I typed in a query. So I typed in meetup here. And if you're thinking about making a visualization about meetups, you might like to see what people have done. And a meetup, it's some free text. It's not an API function. So with tools before, you can search with Google with mixed results, but this is really nice. And so there are some visualizations people have created before with meetups, or data about meetups, and I made one with an adjacency matrix. And not only that, but the API.
Mike, I think there's a question.
Yeah, I'll hear a question.
Do you think it would be cool to add the ability to search with visual things instead of just keywords like a color or shape? So you can get all the visualizations that are like a certain type of visualization, or have this color scheme, or have.
Yeah, I think attribute-based search would be really interesting. I'll show you an example that does something like it, and then later I'll say how you get close to that another way. So I was going to search for D3.
Not use D3 right now. It's like kind of a bug with it.
I should type in just force.
Yeah.
There we go. And so if I pick layout.force, we'll see a lot of examples of networks like I'm going to show you. Oh, I should show this and show many members example. So recently there was a conference about data visualization and design. A large number of the people there and the topics were related to D3. So someone called Shirley Wu created a network of tweets. These are people who posted to Twitter and people they mentioned or tagged in those tweets. And so this is another way you can see the activity of the community removed from the code, but I think still relevant. One other, let's see if I can remember the username. So you asked about color. Let's see. There's a person called Nadia Bremer who is a really fantastic designer. And she has an example where she analyzes all of the colors in all of the D3 examples. And it's pretty remarkable. So yeah, so N Bremer is her username. So I'm doing something, I'm searching for a GitHub username. Blocks.org is a viewer for GitHub gists. So if you want to know who user is, or who, if you want to find a person's D3 examples, you can use their GitHub username. This may appear obvious once you know it, but it was not obvious to me before I did. So if I look at blocks.org and Bremer, I see Nadia Bremer's examples. Recently, she made a few that look at color.
Go in full screen.
I think that's a good idea. So, reading this text to you, more than 4,000 unique colors in 3250 blocks that she looked at. And you can see here the most common colors. So black and white occur really frequently. Grayscale colors also really frequent. And then somewhere you can find steel blue.
I think if you go to one of the other ones,
Yeah, so-
you have an annotated.
So here, or yet another place?
Open that one full screen because there's a button where you can like resize based on.
Yes. So here we're unsized. And sized again. So yeah, perhaps this is steel blue.
Like that.
And so maybe this is an insider thing, but famously, many of the D3 examples early on had this steel blue color. It's Mike Bostock's favorite. So this is some idea of what colors are particularly popular. Other patterns you can find, which I think she wrote in a blog post, are the colors associated with the default color scales of D3. So scales like category 10 or category 20A or 20B, those colors show up for you. So, let's see if I've showed you these. So I showed you block builder search. You might be curious how we build the index, like how do we get all this information? It's public on the internet, but there are many, many gists, like many more gists than there are D3 examples. So it's not feasible, not practical to simply consume all of the gists. So we have this rather interesting method for doing it. So this is a block builder search index, which is a repo that houses the code that identifies and retrieves, identifies gists that are likely D3 blocks. They have an index.html, or they use D3 as a dependency. And then for certain users, it retrieves the metadata and the files for those GitHub gists. And so I'm showing you this page to say there's a repository where it's documented. And the steps are here in the files. You could run your own local node. So I'll tell you this again, but you can get this information. You can index the blocks yourself. If you're curious about how it works, you can go inspect the code. This is open source. It is up there. So with that, I think I'll shift over to this way. So the project I'll show you tonight, I wanted to look in some robust way at the links between blocks, people who mention blocks from their readmes on their own examples. So I unzipped this file that contains lots and lots and lots of D3 examples. And it'll finish playing at some point. Let's go to the next one. I also grabbed some new examples. So here we're putting the ID in the file name as it comes through my console or my terminal. So we do some clever things with the search engine. We keep what we've already found and look for new examples. And so I looked for new examples to get the very latest set of D3 visualizations when I was preparing for this talk. And so I will quickly show you some screenshots of this process. And so here I'm getting even more. This is a bit of the parser. I think I was trying to remember something or communicate something to Ian. And I get them all and I'm done. So when I got all the files, it was about 2.2 gigabytes. That's not including images or thumbnails. And I think before it was a little more than 1 gigabyte, right? So these are a few thousand D3 examples. But the kind of amazing thing is that the pages on the web are not very big. And so it's possible to have all the examples in the world that we can find in a few gigabytes on your laptop. So I guess this is a point from maybe other talks and other meetups, but you can do some things with pretty impressive scope with tools that are pretty accessible. I made some sketches, and I will show you this in full in a moment, but this is a Voronoi overlay where I shade the cells. Voronoi tessellation is this method for drawing shapes that are equally distant from points. And it's nice if you want to be able to select something that's real small. You can just like touch the area all around it and get the thing that's underneath. And there's more. And here I finally get some links working and a screenshot of what I'm going to show you. There's this small cluster. I really wonder what this is. And oh, I made some mistake. And I think it's art. Someone I showed this to thought it reminded him of Calder, who was, I guess, a sculptor in the 20th century US. But yeah, if you don't have your CSS correct, your links may fall away from your nodes, and it looks sort of tragic. So, this is a network of D3 examples. Maybe we have crowd participation. What do you see?
A few concentrations.
Yeah, you see clusters. What else?
Yeah. Colors, color groups, color regions.
Okay. So we see clusters, we see different colors.
There's a weird one down in the corner.
What is it?
Separate from the world.
What is it?
That's the anti-matter cluster.
So this is a multi-series line chart. So let's go click the link here. What's this? So a lot of people recently have been looking at this and forking and creating examples. So let's pick one near it. So some of the details are blank. I think this is a data quality issue. The link is good, but I'm missing some metadata. So Jim has forked the example. He has added labels for cities and this nice background. And here below, there's a message saying it was forked from my CrossX blog, multi-series line chart. So let's inspect a couple other ones. So you can also go out here to like a second level, and I'm clicking, and it takes me in 404s. So let's say that last one, let's see what it is. So you can click on the node. I also added this detail here, so you have like a little bit of history. You can see what has happened recently and perhaps interact with that. So ZC Shark USF created another version. I think the axes are moved. There's some annotation for a really cold day and a really hot day. And there are labels for cities on the right. It's forked here from my CrossX blog, but also from these others. And so I just step back. You might see a pattern in how some of these like references or citations are done. It's because there's a tool that enables them. So a design choice in BlockBuilder, this editor that Ian created, is to add like the lineage or the history of a blog in the README automatically when you click the fork button. So that it actually enables this kind of community visualization in a much bigger, different way than before. I think Ian said to me before that he thinks I should filter it and not show BlockBuilder, like it's somehow artificial. But I think the activity is real. People at University of San Francisco or South Florida, I'm not sure which, are taking a class, and someone told them, persuaded them to fork this block and do something interesting with it. And because there's that real activity out in the world, you see a cluster. And I think that's interesting. Maybe we'll inspect some of these others. So what is this green one?
Is the size of those mean something?
No. So I'll also step back and say, this is a project about creating graph data about the D3 community. I have this interesting project taking the data from the search engine and transforming it to be a nice graph, which I should show you the JSON for that. This is also the beginning of a visualization project. So what I think is minimally useful and something I can show. The practical thing is it's difficult to size dynamically when you have like 3,000 nodes. Question?
Have you ever thought about like image pyramid, and then when you get to a certain level, deciding which SVG to?
Yeah, completely. You can do semantic zooming. Like there are some really nice things you can do.
Like the legends stuff.
So I have a list of like areas to research, and these both go on. So maybe we open this brush block and we can see what it is. So I think this is one person or a small number of people who are working on a genome viewer. I should go back and say something interesting. Their colors, what are the colors? The colors are communities. Maybe I'll show you here. This is something that I learned from Elijah Meeks, who's a person who's written a book and like another like producer of great examples. So there's this Louvain method for community detection, and it's implemented in JavaScript. So you may have used Getme, or you may have used other graph analysis tools. But this is accessible, and it's like on GitHub, and maybe it's a node module, and it will take your network data, your list of edges, and it will find a community. So we can, on their small example here, we can see that it's a static image, but they have a demo. We can find the communities. So let me hop to the live demo, and I'll show you like a very small version of what I've done. Okay, so yeah, they just have the screenshots. Nodes that are close together are a community, and not necessarily connected, or not necessarily all of the connected ones are one community. Here there are multiple colors, multiple communities inside of this extended structure. So you can use k-means to draw shapes. You can use like kernel density estimation. There are like many methods to find communities and segment points. But I particularly like this one because I think it finds useful communities.
Wait, so when I asked about the sizes, I didn't realize, can you zoom in somehow? Like with just the browser zoom?
You totally can.